Hello, I'm Neeraj. Today I will explain a very basic concept. I found that a lot of people needs clarity, like how we can transition from a simple input text to query key and value in the self attention. Because query key and value are the key for all self attentions related mechanisms. So we will try to understand how it actually works. So suppose I take a very simple text with three words, the cat sat. And after that, we already know that we have to create the embeddings. So our embeddings like for the cat and sat, we calculated the embedding vector of size 3. So this is our embedding vector. Now the main issue is how this embedding vector converted into some matrix. For example, suppose we consider here for simplicity, we have a 3 by 3 matrix for query key and value. Then how this will convert into that format. So for that, we will take the weight matrix for query key and value. This is a random weight matrix. So we say that we have a weight matrix for query, that is a 3 by 3 matrix, and we generate it randomly. For example, so this is a random weight matrix. Similarly, we will take random weight matrix for key, that will be again 3 by 3 matrix, and for value, that will be again 3 by 3 matrix. So this is actually weight matrix. Now the issue is, can we generate those matrices fully randomly? Means we can use any kind of randomness to generate such matrix. We can do, but it will affect the quality of the performance. So we control this randomness through three important techniques. First is Javier initializations. So according to the Javier initializations, we can fill the 3 by 3 matrix by randomly selecting the points which are uniformly distributed between the range minus root under 6 divided by root under n plus m, where n is the input dimension and m is the output dimensions, and the higher side range is root under 6 divided by root under n plus m. So between that range, we will select the uniformly distributed points and fill this random matrix. We generally do such kind of things by using numpy. For example, np dot random dot uniform, random dot normal. So some similar ways we are generating such points. So we can say that, okay, fill the points for a 3 by 3 matrix. Similarly, we will fill for key and for value. In a Javier initializations, we can take the normal distributions also in place of uniform distributions by this way. Another way is like key initialization. So we can take the normal distributions between 0 to 2 divided by n is the input dimension. And third is the random initialization. Random initializations, this is not a fully random initializations. We can take the mean equal to 0, and we can take some standard deviations like 0.02 or something very near to that, and then we will select some normal distributions point between 0 to like that. So this way we will select some random 3 by 3 matrices for query key and value. But this is not final. Means even after selection of such kind of values, we have to get the matrices, 3 by 3 matrices for each of those words, because each of those words have we have to identify the relations with respect to each other. So for that, how we can get the query matrix for D. So this is simple. What we will do, we will take the embedding that we have and then multiply it with WQ. Similarly, we will get the embedding, similarly we can get the matrices for query matrices for cat and query matrices for set. Similarly, for key, we can get the matrices like that. And similarly for cat and set. And similarly for value also, we can get like this. And similarly we can repeat it for cat and. So now the initial weight matrices for each of those words are available in the form of 3 by 3. Means we can compare with each other. Now the main part of the algorithm starts from here. Here it is math multiplications. This is actually dot product and used to calculate the similarity. So we can say that similarity score between the and cat. Suppose we want that. So we want to query this against this. So it will be key. So here we will take the dot product between and after that the next part is to scale this. This is very important because we have to avoid the overfitting and exploding gradients. So what we do, we divide it by model size. So here our model size is 3, so we can divide it by 3. This is the size of query and key value matrices. So once we get this, the next part is to get the softmax score. Here what we will do, we will calculate the scaled similarity score for the with respect to all words and with respect to itself, and similarly for each words with respect to each other words. Suppose we want to know the attention weight of this, attention weight or attention score between the and cat, then we will take the for that we will calculate the softmax score between so this way we can get the attention score. Now we will get the attention score for each of those words, means each pair of words. After that, the next part is to get the context vector. So we say it like a context vector. So context vector represents the contextual importance of word with respect to all other words in the text. So here we have 3 words in the sentence. So contextual importance of the will represent the importance of B in the presence of cat and set. So we can say it like a output B will be like attention weight, like attention of the with respect to all word j into value of all words j. So this will give you the actual attention score of word B in the presence of all three words. Now you will say that value Vj is initialized like this. Means we use this type of random matrix to generate the value matrix for each of those words. Similarly for query and key. Now how such kind of randomly generated matrices helps us in getting appropriate results for different context. So the answer is, when you pass the data multiple times and train the sequences, those matrix value will be updated. And after that, you will get the very optimal results for self-attention score. So this is the process, or this is the actual mechanism which actually works behind such kind of systems. Now the important part that I left is mask operation. So in the next part, I will explain what is the use of mask operations. So mask operations are very useful in masked language model and autoregressive language models, and especially for large language models where we use the decoder only architecture. So in the other part of the tutorials, we will try to explain this part also. So for now, we are skipping this part. So I think it will clear your concept, like how the attention system is actually working, and how we can start with a simple text and how we convert it into query key and value and do all the operations, and what are the importance or significance of those operations. So I think you will find this tutorial useful.